Imagine taking the very fabric of matter and convincing it to convert itself into pure energy. This is humanity's most dramatic and dangerous creation. Not all atoms are created equal. Most uranium is U-238, too stubborn to sustain a rapid chain reaction. But its rare cousin, U-235, is different. When a neutron strikes a U-235 nucleus, the atom splits violently apart, releasing enormous energy and, critically, more neutrons. If you gather enough U-235 in one place, a critical mass, those neutrons trigger a runaway chain reaction, multiplying exponentially in microseconds. Plutonium-239 works similarly, but has a nasty temper. It's so unstable, it threatens to pre-detonate itself. The simplest solution was brutally mechanical. Take one subcritical chunk of uranium, place it at one end of a cannon barrel and another at the opposite end. Pack conventional explosive behind the first piece. When detonated, it fires down the barrel like a bullet, slamming into the target to form a supercritical mass. This was Little Boy. So confident were its creators that they never tested it before dropping it on Hiroshima. But plutonium refused to cooperate with the gun method. It would fizzle. Desperate scientists invented something far more elegant. Surround a plutonium sphere with perfectly shaped explosive lenses. When detonated with microsecond precision, these lenses create a spherical shockwave that compresses the core from all sides simultaneously, squeezing it to supercritical density. At the exact moment of maximum compression, a tiny initiator in the center floods the core with neutrons, igniting hell. Pure fission bombs were just the beginning. The true monster, the hydrogen bomb, uses a fission primary to generate X-rays that travel faster than light inside the casing. These rays compress and ignite a secondary stage filled with lithium deuteride, triggering fusion. Fusion releases even more neutrons, which then fission the uranium casing itself. A single bomb thus becomes a cascade of destruction: fission, then fusion, then more fission, each amplifying the last in microseconds of furious energy release.